Active learning means you participate, collaborate with others, and apply concepts to the real world. It requires hard mental effort, but leads to better retention and an understanding of the material that can be transferred to other situations. To understand why active learning works so well, it helps to know that when our brain decides what to remember, it asks itself two fundamental questions. Can I understand? And do I need to know? When you ask, "Can I understand?" your brain always puts the new information on the foundation of existing knowledge. If the foundation is missing, the brain has no idea what to do with it, and as a result, it throws it away. In other words, your brain needs to build foundational neuron connections for new information to attach to, which is both why active learning is more mental work, but also essential for learning. When we ask ourselves, "Do I need to know?" our brain separates between the material it finds worth to remember and the one it can forget. If it's unlikely that new information will ever be used again, the brain is smart enough to throw it away. If your brain finds that the information is needed again, say it could increase your social status, the brain will store it in long-term memory. To stay there and be easily recalled, you just have to periodically use or think of it. To understand how active learning is applied in classrooms, let's look at the teachings of Professor Carl Wieman, a Nobel Prize-winning physicist and a leading proponent of the method. There are 4 steps to it. Step 1. Prior to class, the students read up on the fundamentals of a lesson so they get an idea of the terms and basic phenomena. In class, Professor Wieman starts with a brief introduction and then gives questions to solve. He will have students use clickers, a little device on which students can answer multiple choice questions. Alternatively, or for more complex problems, worksheets can be handed out. Step 2. Wieman projects a problem and asks all the students to select one of 3 possible answers using their clicker. This has 2 benefits. First, the teacher gets an idea of how many of his students already understand the topic. And second, the students are now focused on the question. They want to know if they are right. It is important, though, that the question is both challenging and interesting. All this takes less than 5 minutes. Step 3. Without telling the students how they voted and following Eric Mauser's peer instruction method, which involves questions, peer discussions, votes, and group discussions, the students then discuss the question and their answers with 1 or 2 classmates, ideally with someone who disagrees with their own opinion. During the discussion, the students have to come up with a reason for their answer and why the others may be wrong. Meanwhile, the instructor is circling around, listening in to gauge student thinking and answering brief questions. Then there will be a second clicker vote, and only now the results will be shown. Typically, the second vote will be much better than the first, as students learn a great deal from their discussions. An ideal question will have about 1/3 correct on the first vote and 85% correct on the second. All this takes around 7 minutes. Step 4. Now the professor leads a follow-up discussion with all the students to provide feedback, exploring the different reasoning, which one is correct, and importantly, which is incorrect and why. Only at the very end, Professor Wieman will explain the correct solution and answer follow-up questions. Ascertaining the students' understanding from the questions they ask, he decides if it is time to move on, all of which takes around 10 minutes. There are 3 reasons why active learning works so well. First, the students are actively working on interesting problems. And, as they all voted for an answer right at the beginning, they have a stake in the outcome. That means their brains decide that the information covered is important to be remembered, and are hence more receptive for learning. Second, by solving problems alone and in groups, they dive deeply into the material. Explaining to a peer engages novel mental processes. As a result, they construct new synaptic pathways inside their brains. Third, the explanation from the teacher comes only once the students already formed their own thoughts about the concept. At this point, the explanation makes more sense as the brain can connect the new information to all the thought it had just built. The correct answers have a solid foundation. A large body of research has shown big differences in the outcomes between passive and active learning. In one carefully executed experiment, physics instructors taught their course in 2 ways. Some classes were taught in a conventional style, and others using active learning. Even though the teachers were the same and the students were similar, on average, the active learners doubled their understanding when they were tested at the end of the course. Other experiments have shown that long-term retention is higher as well. Students that take conventional lecture that is followed by a test forget around 90% of the material within 6 months. In an active learning environment, students can retain more than 70% of what they have learned 2 years later. Sometimes, teachers show a problem and then demonstrate to the class how to solve it. They believe that they can just transfer their own thinking into the student's head through an explanation. Unfortunately, for new ideas, a brain doesn't work that way. Unless the brain actively constructs those ideas within, it is as if the material was never heard. How about you? Have you ever learned in an active learning environment? And if so, how does it compare to learning the conventional way? Sprouts videos are published under the Creative Commons license. That means our videos are free and anyone can download, edit, and play them for personal use. And public schools, governments, and nonprofit organizations can also use them for training, online courses, or designing new curriculums. To help us stay independent and support our work, you can join our patrons and contribute. Just visit patreon.com/sprouts. Even $1 can make a difference.